so far about a little bit more than 80 radiocarbon dates for these eruptions. So what are the results? Don't be scared about that plot. We go into more detail later on. That's just an overview of all the cores we sampled, and the red and black layers in here are tephra layers. And we identified 49 primary tephra layers, with 35 having an age younger than 43.5 thousand years. That's just the limit of radiocarbon dating. So we were able to date this 35 eruptions, and the other ones are slightly older. As you can see with the black lines, there are some tephra layers that are widespread, almost all the way from the south to at least Western Sumatra, potentially Northern Sumatra as well, that we can use as marker beds within this course. So looking at the north here with the red triangles, you can see the volcanoes in the north. And these are the locations of the cores we looked at. There are also Salisbury cores here. And as you can see, there we didn't identify too many tephra layers. In total, we identified 7 tephra layers. And we were able to correlate one of these tephra layers, that one up here, with an eruption on land. So this plot is to show you how we do that. We use the chemistry, not just plot element ratios or one element against another, and then compare the on-land composition, which are in red here for YTT, Hopong, and Sinkut, with our marine data. And you can see here nice overlap of the red squares with the blue circles. So we can, and if that's the case for all elements, then we can say that this eruption or this deposit we found in the sediment cores is coming from this eruption on land. So, but overall, there was not so much activity in the north. But looking at Central Sumatra now, we have plenty more cores in that area, but also you can see there are plenty more tephra layers in the Western Sumatra cores. So in total, we identified 32 tephra layers, with 25 being younger than 43.5 thousand years. So within the time span of the last 45,000 years approximately, there were 25 huge eruptions from Western Sumatra. Then looking in the south, we identified 17 tephra layers, but important here is, if you see this black line here, that's the 33,000 Ranau eruption. And if you look above that line, there are not so many eruptions in the record. So most of the 17 eruptions occurred before the Ranau eruption, and in the last 30,000 years, there haven't been that many eruptions. There's the black line up here. You can see the famous 1883 Krakatau eruption, and there's another Krakatau eruption before that. But besides that, there are just a few eruptions here from South Sumatra, even though there's a huge amount of volcanoes on land. Now, to summarize the tephra stratigraphic work we did, we improved the caldera-forming eruption record from 7 known eruptions to 15, all with age and chemistry now. And they are reaching back to 1.2 million years in time. And now looking on the slightly smaller, highly explosive eruptions, we're just looking at the time span up here of the last 50,000 years. We can see here that there are much more eruptions, especially from Western Sumatra. So we have the caldera-forming eruptions of Ranau and Masurai here, and Malintang and Sinkut here. And then we have this huge load of eruptions from Western Sumatra. If we all put them together, what I did here with the gray symbols, we come up with like one eruption every 1.2 to 1.5 thousand years on Sumatra, but with the majority being erupting in Western Sumatra, while there's nearly anything happening in North Sumatra and only little in South Sumatra, especially over the last 30,000 years. So we improved that record from 8 known eruptions in the marine course to 49 eruptions. For the rest of the talk, I will focus on the youngest eruptions from Western Sumatra, so the ones up here. So we call them C1 to C3. They're widespread in the course here of Western Sumatra. And you can see the volcanoes that we found online. There's actually one missing here close to Kirinti. There's another one. But they're widespread, so it must have been a really big eruption. And so we went back earlier this year knowing that there must have been this young eruption, and we were like, okay, we have to find them somewhere on land. And we were driving around all these volcanoes here, and we identified deposits of highly explosive eruptions at Marapi volcano, Tandycart. Then we sampled the Malintang tuff from the big caldera forming eruption, and we found a sample here, or an eruption here at Malintang. These are just some pictures how these deposits look like in the field. So we analyzed them again, and they have quite distinct composition. So with major and trace elements, we can distinguish all the different volcanic centers. So we have Marapi here in black, then it's Malintang in the green triangles, then we have Tandycart is the brown crosses, Malintang is the dark green stars, and there's a sample from Diatas, Lake Diatas, close to Talang volcano in blue. So if we overlap that with our marine data, you can see that C1, the blue symbols here, are overlapping with the Malintang compositions from on land. So this eruption we find in the marine is originated from Malintang volcano. And the C2 and C3, they have actually the exact same composition, even though they form two distinct layers in the marine and overlap with the Tandycart, or with samples from Tandycart. So we're looking closer at those. And this is now looking closer into C1 from Malintang. So Malintang volcano is located up here in the north of Western Sumatra, and we found it in the course here to the south. This is terrain map of the volcano. It's not easy to spot because it's well hidden in the Barisan mountain range, and that's a sensorial photo. We have a small crater here on top filled with a lake, but nothing actually points to a eruption, a recent or relatively recent eruption there. This is a picture how the deposit looked on land, and this is how the marine tephra layer looks like. So it's this reddish layer here within the sediment. So we were dating the sediments by taking a sample, a 1 centimeter sample just below the tephra layer, and dated the small foraminifers in there. And we did it for all 4 cores. And we got 3 ages that overlap fairly well, and 1 slightly older age. That's just because there are older foraminifers in our samples. And we come up with a mean weighted age of about 1,376 years. So about 1,376 years ago, this eruption occurred. And it's therefore the youngest eruption, big eruption from Central Sumatra. But what about the size? So we used the thickness in the marine cores to produce isopach maps, which are lines of the same thickness. So we have a 3 centimeter and a 1 centimeter isopach we were able to construct, and use the method of the Crow. We use the thickness of one of isopach and the area, multiplying it by a factor of 3.69 to calculate a minimum volume for these eruptions. I did this for the 3 centimeter and 1 centimeter isopach, and they come up with quite consistent values of 1.7 to 1.5 cubic kilometers, which is an equivalent to these are really minimum values I will show later. So looking at Tandycart, so Tandycart is located here between the Malintang caldera and the highly active Marapi volcano. It's actually a twin volcano with Singalang in the north and Tandycart in the south. And here's the same as for Malintang, but nothing really, if you look at the aerial pictures, nothing really points to a big young eruption. There's a small, about 1 kilometer crater here filled with a cone at Tandycart, but otherwise it's a well-forested volcano. So this is how it looks in the marine. You can clearly see that there are 2 layers and they look different. We have the C3 here, It's a coarse-grained black and white tephra layer. Here's a close-up from another core. And there's the light gray C2. You can also see here in the other core. So from the marine, it's clearly two different layers. Then we went online and we actually found it's the first and only time that we found a lot of outcrops of the pyroclastic fall deposit on Sumatra, here between Malintang and Tandycart and towards the southwest. And problem was we always just found one, in most of the outcrops, we just found one fallout. But we knew from the marine there must have been two. Luckily, there was one outcrop here down to the south where we identified two units. So we have the Malintang top at the base. Then, yes?
We got the 5 minutes ago. We done just a 5 minutes. Would you like to go into moving faster?
Yeah, no problem. It's not much more.
Okay, go ahead.
Then we have the about 80 centimeter of Malilak 1, then there's some rework horizon in here, and then there's the Malilak 2 on top. So we did the same with the dating then for Malintang. You can nicely see this in green are the samples we took right beneath the C2 layer, and they fairly all have the same age, and we come up with a mean age of about 4,250 years ago. For this eruption, looking at the C3, we get some older ages as well, but 4 nicely overlapping ages here in these cores, giving us an age of about 4,600 years. So within 400 years, this volcano produced 2 massive eruptions that covered most parts of Western Sumatra. So what about the size of this? For Malilak 2, we have the on-land record as well as the marine one. So we were able to get a little bit more precise volumes. So we used Monte Carlo simulation of an exponential method from Fierstein and Nathanson and the power law method of Bonadonna and Horton. We added an error of 20% to our thickness and area, just to account for any mistakes done by measuring. And we're coming up with quite consistent volumes of like 2.3 to 3.4 cubic kilometers for this eruption. Just to show you that we really get minimum values with the Legros method, I did the same thing as before with the 1 and 2 centimeter isotope, coming up with much smaller numbers here. So most likely they underrepresent the volume by a factor of 2 to 3. And for the Malilak 1 or C3 deposit, we just had the marine record, and there we come up with volumes of 2.1 to 2.3 cubic kilometers. So if you take into account that those are minimum values, this was most likely the biggest of those 3 eruptions. So to summarize our work in the last 2 years, we identified and characterized and dated 8 new caldera-forming eruptions on Sumatra. Within the last 1.2 million years, we improved the record of highly explosive eruptions known during the post-Waititi period from 8 to 50. And we identified 3 VIA5 eruptions from central Sumatra within the last 5,000 years and know exactly where they're coming from. This is important for future work to do risk assessment, especially if we account that there's one of these big eruptions every 1,200 to 1,500 years in Sumatra. And yeah, that's also the first comprehensive tephrochronological database for the entire region in Southeast Asia. So I hope I could show you a little bit what we did in the last 2 years, and thank you.
Thank you, Either. Thank you, Mr. Stephen. And then I got information you have been going to Padang before. Is that a surprise for me? And I never knew that. And how's that going to happen? That was incredible, you journey in here. All right, guys, before we are taking you for the next moment to the next keynote speaker, as a fourth keynote speaker for today, if you have any question to Stephen, you just put into the chat room, and then you just click below there or write or type any kind of your question, any kind about volcanology, especially in the West Sumatra. About the volcanology as Stephen present before. So before we're taking the one question or closing statement, I want asking you, even though I'm so surprised knew exactly you have been coming here before. So how's that feeling when you're arriving here, and what in your mind and first time you're coming to West Madam Padang and Physics Department at Universitas Negeri Padang especially?
Uh, it was always a great experience because it means going out to the field, and that's the most fun part of our work. So yeah, it's great to go to the field, and so we were always happy coming to Padang and meeting our colleagues there, and from there heading to the volcanoes in West Sumatra. So yeah, great experience. Always, we were always happy to come back.
Really, you want to become back again, and we can't wait that moment coming after the pandemic, after COVID-19. So I thought we're going through with the limit timing. So what kind of your closing statement about your presentation about the volcanology of the West Sumatra, especially any something a statement from you, Stephen?
Uh, Good question. I think just for you guys, just go out and enjoy the incredible volcanoes you have here. If you have a chance to look at the deposits there and to get an idea of what happened in the past and might happen in the future again, hopefully not too soon. Just enjoy it. I mean, it's a beautiful place, and just have a look at the nature. Just don't pass by, but stop, have a look at the volcanoes and the deposits, and that's already all. If you do that, I'm happy.
All right. Here we go. The last question I thought from Kartika Fajar Kirana. What is the longest age of tetra layer that you have been record?
In our record, it's from the calderas, and it's in North and South Sumatra, about 1.2 million years.
1.2 million years?
Yes,
Oh
that's
my
the
God.
oldest we found so far.
Okay. How far pyroclastic flow you can found was doing research about it from center of month, if the condition is a big eruption, and what is the impact of it?
Um, the, I mean, if you look at the Yangtobata, for example, it's one of the biggest eruptions we know on Earth. There, the
Mhm.
deposits can be found in India, for
Okay.
example. So, and these really big caldera forming eruptions, they cover the entire area of tens to hundreds of meters of material. Even with the fall deposits, we find them in several hundred kilometers away in couple of centimeter thickness. So the impact will be huge. The only good thing is that the wind is mainly blowing towards the sea. So that helps a little, that it, not too many people are, not necessarily too many people are affected, but yeah, let's just hope that there's no really big eruption happening in the next couple of hundred years.
Okay. Thank you, Stephen. Thank you so much for you joining with us for today in this international conference. Buat Bapak dan Ibu dan mahasiswa-mahasiswa fisika, ini pembahasannya adalah bagaimana vulkanologi. Ini kalau kita di fisika adalah geofisika bersama Pak Hamdi. Nanti kalau ada yang ingin melakukan research atau tertarik dengan research yang diadakan oleh Stephen dan Pak Hamdi, ini bisa dihubungi langsung beliau. The next future untuk tugas akhir juga bisa banget kata gitu. Nah, thank you Stephen for your time. And then we are going to the next keynote speaker. Thanks bunch from the Singapore. We can't wait to see you. Alright. Tapi sebelum itu, kita juga ingatkan lagi kepada Bapak dan Ibu untuk yang, oh ya, I forgot it. Buat Bapak dan Ibu, kita ingatkan lagi buat yang masih namanya atau username. Jadi, we're ingatkan lagi, we're reminding you about your username on your account. Over there, like this. Yes. Don't forget, put the username with the right term and condition. Remember, yang pertama, Bapak dan Ibu, tampilkan roomnya. 01, 02, 03, 01, 02, 3, 4, and etc. Setelah itu kasih underscores, setelah itu baru kasih ID. ID ini didapat ketika kita registrasi. Setelah ID baru underscores, baru nama Bapak dan Ibu. Agar masuk nanti setelah ini pada materi para season terakhir, Bapak dan Ibu sudah automatically you find a way your group by yourself. Oke, kita lanjutkan dulu. Kita bersama keynote speaker kita keempat dari Durham University, London. London, but it's going to be United Kingdom, England. Mr. Associate Professor Dr. Halim Kusuma Atmaja sudah bergabung dengan kita. Halo,
Hello? Yeah, can you hear me?
Yeah, absolutely, Mr. Halim. Your name is so familiar, I thought. It's Indonesian name. Is that right?
It is, yes. Yeah. Yeah, they're
Ah,
Indonesia.
so we are going to not conference, but we are going to reunion of Indonesian people. I thought that like that.
Yeah.
All right, ladies and gentlemen, for the last one keynote speaker for today, it's going for, why my accent is going to British? I don't think so. I don't like that. Okay. For the next speaker, we present to you is from Associate Professor Dr. Halim Kusuma Atmaja from Narayan University, it's United Kingdom. And then, Mr. Halim, it's your time. Go ahead.
Great. So let me try to share my screen. I hope it goes
Yeah,
smoothly.
yeah, you can show. Absolutely.
Can you see my screen now?
Yes, absolutely. We can show it.
Okay, great. So let me get started. So first of all, thank you for the organizers for the invitation. So it's a pleasure to give this talk. So last year I was actually in Padang. So it's a really nice place. I was at UNP. So it's good to keep in contact with everyone there. So in this talk, I'm going to go from, Stefan was talking about something that is very big, kilometers, and processes that actually happen in, hundreds of years. So in this talk, I'm going to talk about something which is very small, so micrometer, and things that actually happen in seconds. So very different scales. So that's how amazing physics is, I guess. So I'm going to talk about reconfigurability of 3D elastic mesostructures, and this is joint work with some colleagues in the US. So the groups of Tang Zhang at the University of Syracuse and Sophie Wang at Connecticut. I guess most of you don't know where Durham is, so I thought I'd show you where it is in terms of the map of the UK. So this is what typically the island looks like, and then we're in the northeast, so we're somewhere here. And the University of Durham is actually one of the oldest universities in the UK, so it's the third oldest. And typically, we rank around top five in the UK and then top 100 in the world. So hopefully, some of you will have the chance to visit us at some point. So in my group, we work on a variety of problems related to fluid flows, soft materials, biophysics. So last year I spoke about basically fluids, so the problem of wetting and interfacial phenomena. And I'm happy that Fandi is actually in my group now. So he's actually a lecturer at the University of Padang. But today I'm going to switch gear a little bit. So I'm talking about elastic instability. So let me start by telling you why elastic instability is an interesting problem. So for the longest time, probably until about the 1990s, typically you worry about elastic instability because you want to avoid it. It's often known as buckling. So for example, this is just a cylindrical shell made of whatever materials. And then one thing you probably know is that if you try to compress the cylinder at some point, you get this elastic instability. So this is what we call buckling. So the patterns that you get is actually quite interesting. So people interested in mechanics spend a lot of time trying to understand it. And it's important because, for example, if you are going to structures, so buildings, you can actually have buckling, and this is actually really disastrous for whatever you're trying to do. So your plants, your machineries, it can go really wrong, and then it's very bad. But probably around the year of 2000 and onwards, has been a shift in paradigm where people say, well, elastic instability is generally bad, but actually, if we're smart about it, we can exploit it for applications. So here are just some examples that I'm going to show you the way people now think about this buckling and elastic instability. So one example here that I'll actually talk a little bit again later on is the idea of electronic circuit design. So rather than just designing this in two dimension, if you actually introduce buckling, you can actually design a circuit that goes in the third dimension. So you actually can design, electrical circuits that go in the third dimension. There are some people in Harvard that are actually thinking about using elastic instabilities as the way to code information. So this is an idea where maybe this could be used for some sort of braille wording to actually describe information. And then in some aerospace engineering, there's actually a lot of interest in what we call deployable structures. So structures that can be multi-stable, and then you can actually switch between the stable configurations in a particular rotation or particular deformation. But if you do it in the wrong direction, it's actually very stiff. So these are, in a sense, trying to understand the mechanics. With miniaturization and so forth, there are also interests in trying to use basically this kind of mechanical instability or mechanical deformation for robotics. So I'm going to play a movie from this paper that I thought is, just super cool. So this is from Germany, so from one of the Max Planck Institutes, where they are using elastic materials that can actually interact with magnetic field, and they are basically introducing motion just by playing with the magnetic field. So now I'm going to play the movie. So for example, this is a rolling motion. If you have this material and then you play with the magnetic field, you can introduce the thing to actually roll. And this is even cooler, where the material can actually walk. So this is just a linear motion, but you can actually introduce something more complicated, such as basically moving in a circle. And then all you need to do is basically play with your magnetic field. So it's actually a remote reconfiguration of the materials, right? So this is even trying hard because there's a gap, and then you're trying to cross basically the barrier. So you can imagine there are potentially many applications you can think of if you can control elastic instabilities and then couple this with external perturbations such as magnets. So this brings us to the topic for today. So I'm going to tell you about one type of reconfigurable magnetic structure. And this is typically what you would do experimentally. So take a look at maybe the top left picture for now. So the typical experiments that my colleagues do is that they have an elastomer. So let's say it's a PDMS, and then you stretch this, right? So it has a particular length, and then you try to stretch it because it's elastic. You can do that. And after you stretch it, you actually print some thin film of magnetic materials. So it could be different things. So this is actually presented in blue. And then you clamp the end of this thin films to the elastomer, and this is represented by the bits in red there. Okay, and then what you do next is that you just release the elastic materials, the elastomer, and because of this elastic instability, because of the buckling, you actually go from this flat, thin structure to something that looks like that. So this looks a bit like a table. And then what is even cooler is that if you then introduce perturbations, so for example, you use a magnet, you could actually change the shape from something that looks like a table here to something that looks, some other configuration. Okay. So by doing this, for example, for just this particular case, you can look at the case where it's fully symmetric. So there are four legs and then they're fully symmetric, or 1 feet down and then 3 feet up, or 2 feet down and then 2 feet up. And then because of symmetry, you can actually get a multitude of states. Okay, so then we are interested in understanding how can we control what states are preferable and how many there are. So in physics, we always like what we call phase diagram. So how the behavior of the system depends on various parameters in the system. So we can identify that there are three important energy scales in the problem. So one is gravity. You cannot avoid gravity. So you see that this depends on the density, on the gravitational acceleration, and essentially the size of the system. And because we have elastic material, it also depends on two types of deformation. So stretching, if you actually stretch your material, and then bending, if you bend the material, right? So what you have E here is actually the Young's modulus, and nu is just the Poisson ratio. It doesn't matter if you don't know this. And then because we have three energy scales, we can actually take a ratio between the three. So you end up with two ratios. And then if you vary them, what turns out is that you can actually have region in terms of parameter where there are three different states which are stable and two different states which are stable in blue here, and then the case where there is only one possibility. So experimentally, we can actually realize this by varying various things. So in this case, we just change the size of the system. So we look at something which is centimeters to a micrometer. So that's like going from I, double I, and triple I here. And then we can actually tune how many states that are available. So this is quite important if you want to do applications that at least there are two states which are there. Okay, so if it's only one state, you cannot reconfigure it. It's just basically just one state. So we have some understanding how we can control the number of states, and then that's just one particular structure. Here are just illustration of the different things that you can make with a strategy. So this is what I showed you before. You can have a star that you deform differently, and you can have this this double bridge, we call it. And there are probably about 10 structures that we have tried, and it seems you can actually play this game with a variety of design. So this could be interesting depending on your application. So we actually want to know a bit more. We don't want to just know what states are possible. We also want to figure out how can we actually transition between the states in the best possible way, because for applications, this could be important. So this is basically a study, a combined experimental and theoretical study that we have done to look at how do you change the configuration from one state to another. So the initial state in this case is basically 2 feet down and 2 feet up. And then the final state that you will see later is basically 4 feet going up. And then what you see here is basically what is the energy of the system, and it goes through the change in configuration. So let me just play you this movie. So this is actually one possibility to undergo the transition, where both feet are basically lifting up at the same time, and then you switch from one state to the other. Now, as we have done the study carefully, we find that there is actually multiple ways to go from one state to the other. So it's a bit like if you go hill walking. So if you go walking in the mountains, if you want to go from one place to another, there is more than one possible route, right? So you can take different routes, and then you end up with the same starting point and end point. So in the same way, like that, the same initial state, the same final state. So in this case, we actually get this path where one fit is going up, and actually there's a stable state there, and then the other fit is coming up. Okay, so there are different possibilities to transition. So what we have done is that we look at what we call the energy barrier. So what is the energy you have to introduce to undergo the transition? And this is actually quite important because the structures we have designed are actually multi-stable. So what that means is that you only need to introduce perturbation if you want to switch the state. If you are happy with the state that you're in, you can just leave it like that, and then it will be stable forever. Okay, so in a sense, it's good for energy consumption because you only need energy if you want to switch. And then the energy barrier is basically a mark to basically tell you how much energy you have to input to the system if you want to switch between states. So we look at the energy barriers, and then depending on the size of the system, so remember, by changing the size, we can change the number of states. We can also actually understand now how the energy barrier depends on the size of the system. And therefore, the conclusion at this point is that not only we can actually control the number of states which are available, we can also control how to reconfigure them and how much energy we have to put into the system. So we have really very good control on this meso structure. So basically structures which are in the micron scale. Now, we go also a step further because in the previous cases, all the materials are actually ferromagnetic. They're magnetic. So for some cases, you might not want to do this because it could be expensive, or you might want to introduce other functions to your materials. So we basically try with hybrid materials where what you see in transparent white here is just some basically elastic materials, and the magnets are actually only embedded in these small little patches which are basically black. And then we do the same trick, and then you can actually introduce the reconfiguration. You can actually have multiple stable states. And again, we do the numerical modeling, and then generally we get very good agreement. And then, now that we have this, we ask the questions, well, what kind of applications can you think of? What kind of games can you play? So I'm just going to present you some of the ideas that we have. There could be other things we could try in the future. So one idea is what happens if you introduce some conductive materials. So for example, here, we actually have some conductive patches in the elastic structure. And then at the bottom part, we have some copper that is connected to a power supply. And you can see by introducing this reconfiguration, we can actually switch on and off the LED, right? And then the cool thing here is that all you need is actually a small magnet, and you don't have to do it very close to the structure, as long as the structure basically tries to deform because of the magnetic field. You can also think about putting some cargo, so putting some small particle into the structure. So this is what we are trying with the table structure. We put a small bead here. And then if you switch the configuration, you could think of this as a way to basically transfer the cargo from the structure to the surrounding. So maybe this could be useful for robotics, where you want your small robots to actually carry things and then it drops it somewhere else. Uh, we also thought, well, maybe this is also quite cool for a magnetic pen type application. So what you're seeing here is not just one structure, but an array of structures. And then if you write using your small magnet, you can actually change the configuration from one to another. And this is, for example, illustrated in this movie, where initially all the small structures are actually buckled down. So you can see here. And then my colleague is using a small magnet, and then he was actually switching one at a time. And then what he was trying is to write the letter M. Right. So yeah. So in principle, of course, this is very versatile. You can do different things with it. And then the size of the structure is also quite flexible. So you can do it for, microns to centimeters. So across maybe one or maybe close to two orders of magnitude. Okay, now that we have that, what other things can we do with this kind of study, with this kind of approach? So one project that we are doing is to actually going back to this classical cylindrical buckling, because that's actually important for some industrial applications. And then the idea that we have here is that if we know the buckling modes, so where things can become unstable, then we could actually make certain parts of the cylinder stronger by putting in more materials or materials which are stiffer. So this is one idea that we're thinking. The other idea that we're thinking is actually a problem of origami. So this is, a mixture between art and science. So origami is something that people from Japan likes to do, and now it's spread across the world. And it's basically how to fold papers. So one of the projects we have is to fold papers using, inside the computer, using computer simulation, and predict how is the best way to fold things to get basically the configuration that you're interested in, what is the best pathway, what is the energy you have to put in to do that, and so forth. So I'm going to finish there. So in conclusion, I hope I can show you that we've done a combination of simulation and experiments to show that these days we actually have good control over the number of states and how those states can reconfigure. Uh, these are basically small structures. And then I have shown you that this can be done on a variety of possible structures. So I think really your imagination is the limit here. And then, of course, we are physicists, but we also talk to lots of engineers, and we are thinking how this could be applied basically for applications. So thank you for listening. If you have questions, I'm happy to take them, of course.
Yeah, that's it. Thank you so much, Mr. Halim. If you have a question, you just put into the chat room, because we are sure. And oh my God, I'm so surprised again because I already know before you are coming here before and you're visiting Padang and UNP. Yeah, as you talked to me before, that's a surprise for me as a host. Because in my information, I thought you never coming here because we just knew you are in our lectures over there, Mr. Fandi, like friends, and then like college lecturer, associate professor, and then student in college. Just normal. But you talk to me about the Padang, and how's that feeling? Is that good?
Yeah, yeah. So I like Padang. It's the food is good. The scenery is beautiful. So yeah, I
That the
think
point of.
it's an excellent place. There's so many things to do there.
All right. Uh, yeah, I don't know why the people like the food of Padang. It's so delicious, so yummy, so making our so hearty. So okay, Mr. Halim. So I don't know that the people that the student or participant understand about what we telling and what we talking about. When I saw your chip like a magnet to be like up and down, and that chip moving. That we are discuss a little bit discuss over here in my room. We are surprising. Is that the magnet going to moving, and how that the moving coming? How that cheap to be going up, going down, going side left and right? How's that going? How can be and how could be that cheap?
Yeah, so the magnet at the moment is just controlled in a sense by hand, but of course, this is just for ease of experiment at the moment. But in principle, you can control it in a different way. So that's not really a problem. And then I think the important point to notice is that by combining this with basically elasticity, so something that we probably learn, in our first year or second year of physics, there's actually a lot of things that you can do, because you have these different configurations. You can have different stable states, and then you can think of applications as you try to make things smaller, right? So when you miniaturize applications, and this might be interesting for different reasons, these are strategies that you have to consider that you cannot do easily in comparison to when you have something that is, meter, which is what we are normally working with. So you have to come up with different ways of
We can.
changing states.
Is that able when the student at the college and the level, like a bachelor, can do research like that for that's only for the high level or associate professor research only for that level, or can be able to us in like our junior in the student at university in bachelor maybe the
Yeah,
research.
in principle, yeah, I think actually the main difficulty with the experiment is that so the elastic materials are actually quite cheap. So the difficulty is how do you print in a controlled way when you put in that stripe. So typically what looks like blue in my presentation, because that's quite small, you know, micron scale. So you need some equipment to do that. So if you have that equipment, then actually anyone can do it, because the experiment itself is quite simple, because you literally just stretch and then compress things, and then you just put a magnet to try to move things. So the only expensive thing is just the printing of the thin film.
That the printing expensive, even though we can just easy to describe, but the printing is so expensive about the money. Okay, Mr. Halim, thank you so much for your joining with us to sharing about your presentation, sharing about your lecture city, and then what kind of disclosing statement from you to us, to the participant, for the student of the Padang State University or Universitas Negeri Padang Physics Department, any kind of that?
Uh, yeah, so I guess it's a rather tricky time at the moment with the pandemic and so forth. So I hope everything is going well in Padang. So I hope you still enjoy your study. Um, and then, I think if you study physics, I just want to say that there are so many things that you can do with it. So as you can just from this talk and the previous talk, it spans across problems and processes that go from microns to kilometers. So it's a good time to be a physicist. There are so many things you can usefully do.
Really? It's many things we can do it.
Yeah.
I'm so excited to be like that. Thank you so much, Mr. Halim. We're so glad to having you when you coming to Padang. We welcoming you again. Absolutely can't wait for that moment is coming. Thank you, Mr. Halim. Thanks so much. And then thank you for your say hi to our fellows, Mr. Fandi over there. And thank you
I
so
will.
much,
Yes.
cooperation, attention. Oh my gosh, a lovely moment in this seminar international. All right, ladies and gentlemen, we will going through the parallel season, and it's time to me, your host, akan mengarahkan Bapak dan Ibu untuk akan muncul ke masing-masing grup, dan pastinya seperti tadi sudah diingatkan, rename your name atau your account over there. Don't forget to put your room number, and then after that, underscores your ID in the 3-digit 000 and or any kind of that your ID number, and then after that you just put a underscores and then your name after that moment. By the way, ladies and gentlemen, we have a little bit a demo, no demo tour going presentation of Mr. Halim about Durham University. We don't know about Durham University before, but now we know that Durham is the third university, number third university in UK after Oxford and Cambridge. And then we saw the picture. Someday we will go in there, going to continue our study, going to the PhD maybe sometime. Who knows? Who knows? All right. All right. Thank you so much, Mr. Halim. It's a little touring maybe in the pandemic. So at Durham University. Alright, kalau gitu kita akan langsung menuju masing-masing grup. Kalau gitu Bapak dan Ibu, sampai ketemu lagi di closing ceremony. I'm your host, William Henry. Sign out for your parallel season. See you when I see you again, and kamsahamnida.
Oke, Assalamualaikum warahmatullahi wabarakatuh. Welcome back on parallel session. Sebelum kita mulai parallel session sesi kedua, tadi ada saya kirimkan untuk pengisian absen. Nah, ternyata salah pengisian absen. Ini nanti saya kirimkan kembali untuk pengisian absen yang tadi pagi ya. Silakan Bapak dan Ibu mengisi absen terlebih dahulu untuk yang tadi pagi hadir pada absensi sesi paralel 1 tadi pagi.
Maaf Kak, absennya di mana Kak?
Di chat room ada dikirimkan linknya, chat room. Lihat pada grup 3, klik linknya, nah nanti langsung ke absensi.
Kak, chatroomnya di mana Kak?
Nggak ada Kak.
Chatroomnya di mana bisainnya Kak?
Oh,
Belum Kak. Chatroom di Zoom ini Kak?
udah ada.
Oh sudah.
Nah.
Sudah Kak.
Bagaimana, udah mengisi absennya?
Sudah, Kak.
Belum, Kak.
Oke, ditunggu 1 menit ya. Bagi yang sudah mengisi pada paralel 1, ini untuk link paralel 2-nya, sesi siang ini. Ya, kita lanjutkan ke sesi paralel sesi kita. Untuk presenter berikutnya, yakni Saudari Mutia Faiza, hadir. Mutia Faiza.
Ya.
Oke. Dipersilakan kepada presenter Mutia Faiza untuk mempresentasikan.
Baik, terima kasih kepada moderator.
Share screen-nya dari saya.
Di ya, Kakak ada.
Oke. Baiklah, persilakan kepada pemateri Mutia Faiza.
Ini belum muncul. Belum muncul, Kak.
Belum muncul ya, Sah? Mutia.
Mana nih?
Bagaimana Mutia, udah muncul?
Belum, Kak.
Presenter lainnya?
Di sini muncul, Kak.
Di sini muncul Bu Gita.
Muncul lah, Kak, ya. Kok tidak muncul ya? Atau
Ini
kalau yang
muncul
share
slide
screen boleh, Kak?
presentasinya.
Kita coba Mutia aja yang share screen ya.
Udah muncul nggak?
Belum.
Ini?
Belum. Coba terlebih dahulu dibuka PPT-nya, nanti baru di-share screen ulang.
I'm sorry. Apakah Ibu Putri ada penjelasan tambahan untuk menutup presentasinya?
Okay, maybe the participant, okay, all the students not ya. Mungkin penjelasan saya mungkin lebih luas Indonesia aja ya. Nah, mungkin program yang akan dikembangkan ini adalah sebuah metode penugasan yang dikemas dalam bentuk interaktif, karena kita tahu selama ini sekarang ini kita mengalami ya, atau di masa pandemi ini tentu tidak bisa bertatap muka, jadi hal-hal yang berkaitan dengan media pembelajaran itu terpaksa kita ubah menjadi interaktif yang bisa diakses ya, daring ya, luring. Jadi produknya ini sebuah kumpulan-kumpulan soal ya, konseptual ataupun yang bersifat high order thinking. Nah, dari soal yang dikemas itu dari option jawabannya itu akan disediakan any feedback. Jadi ketika siswa atau mahasiswa menjawab option yang salah, nah mereka akan tahu di mana kesalahan mereka, di mana kelemahannya. Nah, sehingga dia akan bisa memperbaiki ke soal yang berikutnya tidak terjadi kesalahan yang sama. Maybe that's all. Thank you.
Okay, thank you very much for Mrs. Putri. I think the explanation is more than enough, I think. So the audience, nobody wanna give the question to Mrs. Putri? If nobody have the question, we will continue to the next speaker. I will call Mr. Abdul Haris. Mr. Abdul?
Oh, yeah.
Are you ready?
Yeah.
Yes, okay.
Yeah.
You can share the PowerPoint. Okay. Please take your time.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm sorry, I present in Indonesian. Saya akan coba mempresentasikan hasil penelitian kami. Penelitian kami ini merupakan bagian dari penelitian pengembangan. Jadi bagian awal daripada penelitian pengembangan untuk mengembangkan pembelajaran berbasis blended learning. Tapi sebelum penelitian turun ataupun meneliti pandemi COVID-19 itu sudah melanda, sehingga kami melakukan analisis terkait pembelajaran blended learning dan dikaitkan dengan COVID-19. Adapun ini pendahuluan daripada ataupun latar belakang daripada penelitian kami, bahwa menurut data survei atau Indonesia Internet Survey Provider Association, dalam hal ini Asosiasi Penyelenggara Jasa Internet Indonesia merilis bahwa jumlah pengguna di internet di Indonesia itu adalah sekitar 143,26 juta atau sekitar 54,68%, dan dari 262 juta penduduk Indonesia. Dan ini data tahun 2017. Nah, data ini pun menurut APJ itu meningkat setiap tahun. Nah, sekarang sudah 2020, pastilah pengguna internet yang ada di Indonesia itu sudah lebih dari 54,68%. Maka dengan itu kami tertarik untuk melakukan pengembangan pembelajaran untuk yang terkait dengan pembelajaran blended, artinya untuk pembelajaran yang mengkombinasikan antara pembelajaran tatap muka dengan pembelajaran online yang dalam hal ini melibatkan perangkat komputer dan internet. Tetapi pada saat kami akan melakukan penelitian, wabah COVID-19 itu di seluruh dunia itu mewabah, termasuk di Indonesia, dan hal ini membuat pembelajaran online yang awalnya itu sangat-sangat terbatas itu menjadi fokus perhatian. Nah, berikutnya beberapa platform daripada pembelajaran online itu sudah tersedia di secara gratis, misalnya saja platform untuk pembelajaran yang kita menggunakan Edmodo atau menggunakan Google Classroom dan seterusnya. Platform-platform ini tersedia, tetapi pada saat COVID-19 guru-guru dan siswa itu tidak memiliki keterampilan ataupun pengetahuan menggunakan pembelajaran dengan platform tersebut seperti Google Meet, seperti Google Classroom ataupun Edmodo yang sering kita gunakan. Nah, salah satu yang mudah mereka lakukan adalah menggunakan sosial media di dalam pembelajaran. Nah, sosial media yang digunakan di dalam pembelajaran terkhusus untuk di COVID-19 yang paling besar adalah yaitu WhatsApp, Facebook, Messenger, ataupun Instagram. Nah, pemanfaatan media sosial dalam pembelajaran fisika, khususnya pada masa pandemi untuk tingkat SMP sampai SMA itu sangat besar. Karena memang seperti yang saya katakan tadi, bahwa untuk daerah yang misalnya untuk Gorontalo itu sendiri, bahwa sebagian besar guru ataupun siswa belum mengenal platform yang saya sebutkan tadi seperti Google Classroom maupun Edmodo. Adapun metode yang saya gunakan, karena ini merupakan penelitian awal ataupun analisis bagian daripada penelitian pengembangan, maka ini merupakan penelitian mixed method, yaitu penelitian kombinasi dengan menekankan pada data kualitatif. Kami menggunakan strategi sekuen eksplorasi atau strategi eksploratif. Itu dalam pengolahan data itu lebih pada menunjukkan data-data
design and manufacture of a book based on scientific approach on the National Geopark of Ranah Minang Sulawesi, Indonesia. The first point, introduction. The information technology and communication development as time go by target various sector of life, and education is not except. The first, the background research is the mind for IT development in education. The second background research is the ability can be first in the learning complex aspects of the development in information technology and communication is utilization of the environment as a learning resource. But in reality, not yet using approach. The second research background in reality, teachers still often use print teaching materials, and the last teaching material have not been integrated in with EduPart. moving away from this issue. So your need requires not brain learning source that step in potential area. You can see the cover is seen. So the purpose is research. The first, to produce the design and manufacture of the ebook of science edupart. The second, be able to address on the thanks for the development of the 21st century in the development of the technology-based learning. The second point, research and method. The kind of the research carried of the development research is educational design research, or EDR. The model of the development use of plum models. The study is a primary research phase that was done, and this type of study was called the produce particular products and test is validated.
Every human activity is supported by energy. Solar cell and characteristic. Solar cell are an active element that convert light energy into electrical energy with a principle called the photovoltaic effect, with positive and negative pole. When light fall on the surface of the solar cell, a voltage different will arise. Jadi di solar cell ini intinya kita menggunakan sistem yang seperti dioda, bisa memanen energi dengan konsep positif dan negatif, whole ya, whole positif negatif. And then maximum power point tracking. Maximum power point tracking is an electronic system that must be in a PV system so that the system can produce maximum power. MPPT is not a mechanical tracking system that is used to change the module position to the sun's position for maximum energy. In a PV system, the MPPT circuit is on the charge controller and inverter side. Di maximum power point tracking ini sistemnya bukan mekanik tapi sistemnya elektronik, sehingga energi matahari yang bisa kita serap bisa dimaksimalkan dengan kondisi apapun di lingkungan seperti itu. And then diagram block solar cell harvest energy, measure current and voltage, control with MPPT. MPPT-nya DC-DC converter. Output and put electronic and saved by battery and other. In this schematic, MPPT in solar cell, sensors, current sensor, voltage sensor, MPPT system with Arduino or microcontroller other, and then system software system in the Arduino, then voltage measure and current. Schematics in this flow chart. Ini result and discussion. MPPT solar in this MPPT system based on the IV characteristic graph of solar cell above, it can be send the voltage and current output of the solar cell with change according to the in load. This will result in change in the output power of the solar cell and enter the circuit. In measuring of the output power of solar cell, track the MPPT driver and connect to the load in the home resistor. In this graphic of MPPT and not MPPT, blue not MPPT, red with MPPT. In this condition with MPPT power and this not MPPT. Okay, conclusion, the MPPT driver output power is the peak of the solar cell power and remains stable with a give load value variation. The output characteristic of solar cell when without solar irradiation will reduce the value of the current and if it can be mined at a certain voltage value. Nah, intinya kalau tidak menggunakan MPPT system, maka yang diserap oleh sel surya itu tergantung dari radiasi matahari. Kadang ketika ada penghalang seperti awan atau kondisi hujan, maka MPPT yang diserap oleh sel surya tidak maksimal. Makanya di backup oleh MPPT. Oke, thanks.
Okay, thank you for Mr. Rizwan, who has already present his research about an efficient use of electric power controller from MPPT solar charge. So, menurut yang saya tangkap, berarti ini bergantung pada cuaca ya, Pak?
Iya.
Oke. Kepada seluruh peserta, apakah ada yang ingin ditanyakan? Bagi yang ingin bertanya, silakan.
Teaching material of on semester 1, like analysis number 2, analysis of physics teaching material based on STEM semester 2. I get data like that. S and M dominant. So this is the result of Marison, Robert, and Pangesti for STEM. Marison said the STEM approach makes students able to solve problems, to be better, innovative, independent, logical thinking, and technological literacy. And Robert said STEM-based learning can add to the learning experience through practical activity and apply general principle of the material being studied. So the student who get STEM integrated learning have better learning outcome. Pangesti said learning related to STEM aspect provides the opportunity for students to understand the concept of physics combined with technology, engineering, and mathematics through discussion, practicum, and project creation. The activity carried out during the learning process can attract student interest and have implication for improving learning outcome. So, conclusion of my research. 1. The STEM approach needs to be applied in 21st century education because the STEM approach makes students have problem-solving skills that indispensable in 21st century. Number 2, the present take of physics teaching material based on the STEM show a rank of 14 until 65 in the inadequate category. Artinya di sini bahan ajar yang berbasis STEM itu baru dalam kategori cukup. So number 3, the benefit of learning using STEM teaching material are that students are able to solve problems to be better, innovative, independent, logical thinking, and technological literacy, encouraging interest in learning and student learning outcome.
I have to conduct in laboratorium in school laboratory, but based on my analysis before, not only a school have the complete equipment, and especially today we are in pandemic COVID-19 pandemic, so we can make the virtual laboratory of this topic: listrik statis, rangkaian listrik, and kemagnetan. Next, I will tell about student analysis. Based of my observation in school, the student get low scores in science learning, student have of motivation in science learning, and student rarely get practical experience. So, based on this condition, we need the student. I conclude that student need practical work activities. Next, the third, this is analysis of the condition. Based on my research, not all the teachers conduct practical work for electricity and magnetic in science learning junior high school. It not be carried out in school laboratory. Case of the first practical work equipment is not complete, and then teacher competence is not adequate to carry out practical work, and then duration of learning is not enough to practical work. And then the special case like this, there is COVID-19 pandemic that makes learning unable to take place face to face, and then students and teachers need practical activities. They are not limited by time and place. So based on student analysis, curriculum analysis, condition analysis, I recommend to develop a virtual laboratory. And for today, because we need the smartphone, need the handphone, this virtual laboratory can be developed based on Android. So in the next research, I will develop mobile virtual laboratory for electricity and magnetic topic materials. That's all, I think. Thank you, moderator. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. It was a specific presentation. That's a good solution for the pandemic situation. Now, let we start the next participant. I call Miss Kusnul Khotimah to present the result of her research. Once more for Miss Kusnul Khotimah.
factor of student less conceptual understanding. Many students still strongly hold and even use the wrong basic knowledge in solving the problem. Therefore, one of the way to know student understanding about physics concept is by using tests. Literature study, test instrument, and conceptual understanding. Research method, tip of researchnya R&D, the development model 4D. Defining state is divided into some state, namely point 1 initial analysis, point 2 student analysis, point 3 test analysis, point 4 conceptual analysis, and 5 purpose specification. The stake design convert to stake such as to stake once test argument and to the initial design. The product development stake convert to stake, namely one expert validation, two product trial, three question item analysis, and four final product of the test instrument. Okay. Research method. According to Amin, the formula used to get the percent of each. Sorry. Okay, tunggu. Wait. Hmm, okay, sorry. Uh, okay, sorry. Okay. Okay. According to Amin, the formula used to get the percent of each statement item is as follow. See, okay, the value result in the percent scale stating the instrument is valid or need to be revised. The validity criteria of the test instrument is divided into four criteria: extremely valid, sufficiently valid, and less valid, and invalid. Okay. Next. Research method, the valid test instrument then was test on the student to know the feasibility level of the product being developed. The subject of product trial were 100 students. Uh, then the trial result of the test instrument then was analyzed for the validity of question item, the reliability, the difficulty level, and the distinguish power. This is criteria and this is formula. Okay, result and discussion. The result of this research and development is elaborated for each research stake. Stake 1 define. Point one, the initial stake. Point 2, student analysis, assessment analysis, conceptual analysis, and purposes specification. Stake design. Point 1, the test arrangement. Point 2, the initial design. In this stake product, the test instrument of level conceptual change contextual based on the material of direct electric current to active the resource theory. Kemudian next stake development. Point 1 expert validation and point 2 product trial. This result. Okay, based on table 3 found that the analysis result of test instrument validity, this description utilized until 1 until 16 has zero correlation. All questions have valid category with medium, high, and extremely high interpretation, and reliability value obtained is 0.90 with interpretation extremely high. Okay, discussionnya. Development of this test instrument aims to present test question item of level conceptual change contextual based on direct electric current material for activating the resource theory that can be used to measure student conceptual understanding. In this result, the researcher developed seven sub-concepts of direct electric current material, such as strong currents, resistance, and resistivity, Ohm law, electric energy, electric power, electric series, and Kirchhoff law. From the result of expert assessment, obtained that the product validity is said extremely valid with feasibility test by the expert in the amount of okay, this result show that this product is feasible to be tested. The reliability of test instrument is also state reliable because based on the reliability instrument conductive obtain the score in the amount 0.90 with extremely high interpretation. Okay. Okay. This. Mm, mm, mm. Okay. This the next discussion. In the level of difficulty based on the analysis of question, difficulty level offering is 0.36 with medium category. Uh, it means all question tests are not too easy and not too difficult. Until overall, the difficulty level of this instrument of level conceptual chain contextual based on direct electric current for activating the resource theory is good already. Based on the result of test instrument, distinct power in the mode of three question have for distinguished power, three question item have for distinguished power, and five question item have good distinguished power, and five question item have excellent distinguished power. Conclusion, after conducting the test of validity, reliability, difficulty level, and distinguished level of the question, the instrument has own good score of validity, reliability, difficult level, and distinguished power equation. Then the test instrument of level conceptual change, contextual based on direct electric current material to active the resource theory with total 15 items can be used to measure the student conceptual understanding. Mm, right. Sorry. Mm, okay. Um, okay. Okay, Miss.
Okay, thank you so much, Miss Dian, for your presentation.
Yes.
And now we have one question from Miss Nurul that you would like to answer. Are the questions in this instrument consist of quantitative questions or qualitative questions only? Okay, please, Miss Dian, you may answer this question.
Oke, saya jawab pakai bahasa Indonesia aja ya. Penelitian ini instrumen yang di sini tanyakan pertanyaan tentang instrumen ini pakai kuantitatif atau kualitatif. Pada penelitian ini
function in the MATLAB, for example, for gray trace, so you can convert the picture of the X-ray image from the black or the white into the white and the black. So you can use also the invariance function. It's already available in the MATLAB, and then region props to characterize to show about the connected component inside the image. So for further next steps, so we plot the characteristic of the bubble, such as the volume on surface. So this is the flowchart methodology for image processing. So this is the result and discussion. And then we can see this is for the DG sample and W3 from Onicobe sample, and then XY from the Ramades volcano in Chile. So basically you can't see anything because it's almost the same, I mean, for linear decreasing. Yeah, I think this is only one tail in here, so you can't see anything because it's almost similar. But also in from the volume versus the surface of the bubble, so you can see the plots. This is the theory. So basically, it describes this perfect circle in here. So basically, you can interpret the data. So basically, the bubble is much more elongated in here. So yeah, some of them you can see this is a perfect circle, a pure sphere, but you can see mostly they are elongated. Also in from the Chile volcano. So for the plot orientation, you can see like this is for the from the Onikobe from Japan sample and this is from Chile sample. So the good thing in the unique thing in in the Chile sample. So basically you can see they are more concentrated in the middle. So basically you can see they are varying in the axis of the vertical. So you can see, so that's why you can see this is the vertical axis in here, because they from the orientation you can see they are more concentrated in the center. In contrast to the Japan sample, you can see they are varying and varying in the widely points in the sphere. So you can see that they are mixed. I mean, you can see in concentration in the middle and also in the edge of the sphere plots. For the DG sample, you can see you can only see in the edge of the sphere in here, but you can, yeah, some of them you can see in the middle, in the center of the sphere, but they are much more in the edge of the sphere. Okay, so the conclusion is for the analyzing in 3 different samples using the image processing, you can analyze
9,6 AU pada panjang gelombang 500 nanometer. Panjang gelombang ini tergolong pada spektrum gelombang cahaya tampak dengan warna hijau. Efek logam berat terhadap relatif bioluminescence jamur. Pada grafik dapat dilihat bahwa konsentrasi logam berat tersebut sangat berpengaruh pada intensitas bioluminesensi jamur bercahaya. Jika konsentrasi logam berat semakin besar, maka intensitas bioluminesensi semakin kecil. Jenis logam berat berpengaruh terhadap intensitas bioluminesensi jamur bercahaya. Penurunan intensitas paling besar terjadi pada tembaga, kemudian besi, dan selanjutnya seng, dan yang paling kecil yaitu timbal, logam berat timbal. Selanjutnya, pengaruh konsentrasi terhadap koefisien inhibisi jamur pada bioluminesensi. Dapat dilihat pada grafik bahwa semakin besar konsentrasi logam berat, maka nilai koefisien inhibisi semakin kecil. Koefisien inhibisi terbesar karena adanya logam berat terjadi pada tembaga, logam berat besi, logam berat seng, dan yang paling kecil itu logam berat timbal. Selanjutnya pembahasan, if the concentration of heavy metals is greater, the intensity of bioluminescence will decrease. The inhibition coefficient value obtained from the decrease in the intensity of light emitting from the inhibition coefficient value of the four types of heavy metals obtained. It can be seen that copper has the largest inhibition coefficient value than iron, zinc, and the smallest is lead. Summary, if the concentration of heavy metals is greater, the intensity of bioluminescence will decrease.
The inhibition coefficient of bioluminescence of luminous mushroom decrease with increasing concentration of heavy metals. If the heavy metals concentration is greater, the inhibition coefficient will be smaller. The greatest inhibition coefficient due to the presence of heavy metal occurs in copper, then iron, zinc, and the smallest is lead. Thank you for attention.
Okay, thank you for the presentation. It's an interesting research what you have done. Maybe the participant in this room or another presenter want to ask about her research. Any question? Okay, I saw the greenish fungus mushroom in your presentation, and how we can see the greenish mushroom. We can see with naked eye, or it radiates with UV lamp or something.
Baik, Mr. Rahmat, ini akan menjawab. Jamur adalah tumbuhan tidak berklorofil yang bersifat heterotrof, dan tubuhnya terdiri dari benang-benang halus yang disebut hifa atau sel jamur. Di sini, logam berat yang ada di udara itu diperkirakan dapat terakumulasi pada jamur. Apabila jamur tadi terakumulasi pada logam berat, maka intensitas cahaya yang ada pada jamur itu akan menurun. Lama-kelamaan, cahaya yang dimiliki oleh jamur itu akan padam dan jamur tersebut akan mati. Terima kasih.
Oke, baik. Jadi cahaya hijaunya itu bisa kita lihat secara langsung ya,
iya,
dengan mata.
Bisa, Pak.
Okay, good. Good luck for your research and hope you have a good research in the future. Thank you. For the next presentation, let me present my research in this parallel session. Andy?
Oh, boleh. Aku yang kalau gambarnya.
Okay, I will present my research right now with title Transformation of Coconut Shell into Graphene-like Material. We do a literature review, so we present the literature review in this presentation. I do with my colleague, Ms. Fadial Faljora, in Material and Biophysics Laboratory, Universitas Negeri Padang. In this occasion, I divided my present into 4 parts. First, introduction. Second, method to convert coconut shell into graphene-like material, and application of the product, and future research related to the graphene-like material-based coconut shell. Introduction. We know graphene is a two-dimensional material of hexagonal carbon lattice with sp2 bond. So we see the graphene is like a layer with consists of carbon atom. We see the atomic structure of graphene in this picture. After the properties of graphene is revealed, the researchers found that many superior properties of graphene, such as mechanical property, it has 1 terapascal modulus Young, and electrical properties is very good with electromobility up to 250,000 centimeter per square per volt second. And besides that, graphene is a transparent material with transmittance up to 90%, and it has thermal conductivity with thermal conductivity 5,300 watt per meter Kelvin. It also a flexible material, can stretch up to 20%, and have a surface area up to 2,600 meter square per gram. With superb properties, the graphene can be applied in many fields, such as in semiconductor, we can find graphene in high-speed transistor, and we find it in a flexible touch screen or touch panel, and combination of electrical and optical properties make graphene enable to apply air solar cell and energy harvester such as supercapacitor or battery. Graphene is also be applied in as LED and chemical sensor and conductive ink. So if we see the ink that can serve as a cable, so it give like good electrical property, it based on graphene. And the graphene can be synthesized by several methods. The first rise of graphene is synthesized by Scotch tape method, the decleavage of the layer of the graphite flakes. It's done by Novoselov. With it give the Novoselov the Nobel Prize. And by epithelial growth, heating the silicon carbide substrate in high temperature. Unfortunately, this method cannot transfer the graphene gastrate into another substrate. Chemical vapor deposition, or CVD, by depositing the carbon vapor of methane and ethane. Unfortunately, this method is very expensive and very difficult to do. And reduction of graphene oxide, use the graphite by oxidating with strong acid and produce graphite oxide. And graphite oxide is cleavage by mechanical exfoliation using the resulting the graphene oxide. Then graphene oxide is reduced and finally produce the reduced graphene oxide. But the high cost of precursor and method need alternative resource. And one of the candidate of the alternative is biowaste. Biowaste have been applied for as another alternative of the carbon source, which are sugar cane and coconut shell, rice husk.
0,83. Kemudian yang terakhir kita ke conclusion, di mana conclusionnya setelah saya melakukan validasi, di situ sudah dinyatakan valid, di mana menunjukkan angka lebih besar daripada 0,6, yaitu 0,8, yang multimedianya terdiri dari 3 sesi yang seperti saya jelaskan tadi. Nah, untuk sesi selanjutnya akan dilanjutkan pada tahapan plum berikutnya gitu. Okay, enough with my presentation. Thank you.
Okay, thank you for your explanation. Okay, for all of the participants, I cannot see the question in the box chat. Okay, so you can give the question directly to Mrs. Nudia. I give you 2 minutes. Okay. Okay. No question? Okay. I think enough for your presentation.
For each instrument, we can see on the table 5 instruments assess valid category and 5 other 2. All of instruments are valid category. We also use this instrument to measure validity of product. Our product, video based context video, and 2 validator give the same validity. This data means the instruments are reliable. From 2 group of data, we can conclusion of all instruments that has been developed are valid and reliable. Or the instrument we are developed valid to measure quality of CTL based video. Thank you.
Okay, thank you so much, ma'am, for your presentation. And now we have collect one question for you, and from Ms. Nurul, and the question is, why we need more instruments to measure a product? Okay, ma'am, please answer the question.
Yeah, we need some instrument to collect data about quality of videos, like physicist expert is different from learning physics expert. And so we need 2 instruments to measure the validity of videos menurut expert, ya, menurut expert. And then if we can, if you want to measure the effective of the video, we need 4. We need to measure 4 skills: creative, collaboration, and communication. There are 2 communication, oral and written communication. Ya, tentu saja we need all of instrument to all out measure quality of contextual based videos learning. In this research, especially for fluid, static, and dynamic. Thank you.
Okay, thank you, ma'am, for the answer. And for the participant who has still a question for Ms. Desnita, you may type your question in the chat room below. Okay. Oh, okay. As we can hear together, the azan has been witnessed. So thank you, Ms. Desnita, for your sharing your topic here with us. Thank you very much.
Welcome. You're welcome.
Okay, thank you so much. Now we come to the break time. We will give 10 minutes for all the participants to have the asar pray. And we will back here at 3:50 p.m. At 3:50 p.m. But before we go into break time, I would like to ask for all of the participants to on the camera.
Diskusikan kemarin, tunggu sebentar, kita lihat ini gambarnya. Viskositas ya, yang seharusnya kalau kita lihat itu komposisi airnya dan viskositasnya semakin tinggi, kemudian kan menurun, kita lihat di sini, sehingga dia menjadikan posisi perubahan-perubahan di daerah mendekati kemana dia. Karena ini dalam ternyata ini kan sudut tepi-tepinya kita bisa lihat, di tengahnya bagaimana, komposisinya berapa merapat segala macam, di situ yang kita melihat. Sehingga pada komposisi air, kalau kita lihat dari antara lebih dari 50% airnya, itu viskositasnya juga menurun. Secara logikanya kita akan melihat bahwa air banyak itu viskositasnya akan apa? Merendah. Nah, tetapi di sini dalam ternak apabila kita menggabungkan ketiganya itu akibat dari surfaktan dan si kombinasi oil yang kita pakai yang ini kita menggunakan pentanol sebagai oilnya. Itulah kombinasi-kombinasi yang menyebabkan terjadinya penurunan daripada viskositas karena peningkatan dari oilnya.
Okay, thank you for your answer, sir. And terima kasih juga kepada saudara Adika Bagaskara yang sudah bertanya. Terima kasih atas partisipasinya. Selanjutnya, baiklah, saya rasa semua presenter di sini sudah melakukan presentasi mengenai penelitiannya. Selanjutnya, di sesi terakhir, di sesi selanjutnya yaitu kita akan melakukan foto bersama. Jadi untuk kepada seluruh peserta agar dapat membentuk okay sign, make okay sign, and find your best position so you will look professional on your camera. Okay, can you make okay sign? And hold on for 10 seconds. Okay. To Mr. Marzuki, please turn on your camera. 1, 2, 3. Okay, one more time. 1, 2, 3. Okay, thank you. And for all participants, please stay on your Zoom application until our closing ceremony. And because it's already 3:41, so it's time to break for take a break. And for all participants, we will write back maybe on closing ceremony because of our presenter already present her presentation. Okay, I think that's all for this session. Thanks for all your participation and thanks for your attention. I'm sorry if there was a mistake during this session, and thanks for your attention. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Kepada seluruh peserta agar dapat bertahan pada Zoom aplikasinya sampai closing ceremony nanti. Dan sekarang adalah waktunya break, jadi dipersilakan untuk sholat dan mungkin makan, dipersilakan. Jadi jangan meninggalkan Zoom. Terima kasih.
polymerization, but spin configured copper ferrite is smooth, morphology is smooth, and pore diameter or large pore diameter. And with DX, we know spin configured copper ferrite contain atom copper, ferrite, sodium, aluminum, silicate, and potassium. Effect flow rate. When methylene blue flow with a flow rate 0.8 and 1.2 milli per minute, it can be seen jika makin cepat laju alirnya, maka itu lebih kurvanya lebih tajam dibandingkan dengan jika laju alirnya lebih lambat, dia lebih landai. Ya, artinya bahwa kalau makin lambat laju alirnya, makin lama waktu untuk mencapai titik jenuhnya dibandingkan dengan jika laju alirnya lebih cepat, maka lebih cepat mencapai titik jenuhnya. Artinya bahwa untuk laju alir 0,5 mili per menit diperlukan waktu 120 menit untuk mencapai titik jenuh. Sementara jika laju alirnya 1,2 mili per menit, diperlukan waktu 200 menit untuk mencapai titik jenuhnya. And second, effect of mass absorption on CE per CO, kita lihat hasilnya sama. Jika makin banyak berat absorben digunakan, maka dia lebih landai, seperti ditunjukkan warna merah. Warna biru menunjukkan berat absorben digunakan adalah 0,5 gram, sementara yang warna merah menunjukkan absorben digunakan 1 gram. Jadi kalau makin banyak absorbennya, artinya makin tinggi kolomnya, itu makin banyak volume yang diolah oleh absorben tersebut. Kita lihat di sini bahwa untuk mencapai dengan flow rate 1,2 per mili, itu memerlukan waktu 240 menit jika kita gunakan absorben 1 gram. Kemudian untuk absorben yang telah jenuh dengan methylene blue dapat kita regenerasi atau kita destruksi menggunakan NaOH 0,1M. Di sini makin lama kita mendestruksinya, maka makin banyak methylene blue yang terdestruksi. Kita lihat di sini, jika 30 menit kita gunakan untuk mengaduk absorben yang mengandung methylene blue, itu hanya bisa mengeluarkan 80% methylene blue. Sementara pada waktu 50 menit, hampir 95% lebih methylene blue dapat dikeluarkan dari absorben. Jadi artinya makin lama waktu, tapi dalam waktu 60 nilainya tetap. Artinya paling tinggi 50 menit semua methylene blue yang ada pada absorben akan dikeluarkan oleh NaOH. Conclusion. Optimal absorption curve at an absorben with 10 gram at flow rate 0.8 mil per minute and concentration of 200 ppm, Kb and Ka 25 and 15 milligram per gram. If the absorbed flow rate increase, the absorption increase, absorbed volume increase, and the value of Kb and Ka will be small. Optimal absorption occur at an absorbed flow rate 0.8 at 1 gram absorben weight and 400 ppm gram of methylene blue, Kb and Ka 25 milligram per gram and 15 milligram per gram. Thank you. I think I finish a presentation and thank you for moderator.
Oke, baik, terima kasih Ibu Erdawati for the presentation. It's very interesting. Are there any question from the another participant or presenter? Okay, there is one question from Sandiano. Did you use best way for got the data, ma'am? Or can use the another way to get it?
I'm sorry, good the data. Good the data.
Got, maaf maksudnya. Let's get. Baik, pertanyaannya, Ibu, maaf sebelumnya, apakah ini metode yang sudah baik untuk mendapatkan data? Oke.
Metode sudah baik untuk mendapatkan data. Metode kolom adsorpsi. Kolom adsorption.
Ya, barangkali itu maksudnya, Ibu.
Yes, kita menggunakan tabung infus. So, methylene blue dimasukkan ke dalam tabung infus. Kemudian tabung infus dihubungkan dengan kolom. Kolom diisi dengan adsorben. Kemudian methylene blue dialirkan ke dalam adsorben dan filtrat atau effluentnya ditampung dalam waktu tertentu. Jadi pada interval 10, 20, 40 menit dan seterusnya.
Oke, jadi metode column absorption ini metode yang umum digunakan ya, Ibu ya?
Umum, ya, iya.
Baik. Oke, baik, terima kasih. Are there another question for Ibu Herdawati? Okay, if there is no question, we will say thank to Ibu Herdawati for her presentation, and finally we will invite the last presenter in our room. He is Mr. Trengginas Eka Putra. To Mr. Trengginas, the time is yours.
Okay, thank you for the permission. I'll share my screen. Okay, this is my research with the title Nonlinear Dynamics of Modified Paired Dissolved DNA Model in No Super Thermostat. For the very first time, I'm sorry for my broken English if I couldn't understand so well what I'm talking about. And this is my name, and with also my partner. Okay, this is the outline, what I will talking about. Introduction, Hamiltonian in DNA system, the super thermostat, numerical result, and also conclusion in the end. So let's check out the first one, introduction. Okay. So DNA is a genetic material, has been engineered for various purposes. And today, DNA engineering has developed very rapidly in the last decade, especially in the field of communication and technology. But at the present, some branches of biomolecular science have discussed DNA in detail, but their perspective can only interpret DNA just in static way. So both encryption and description process of DNA genetic codes are very difficult to observe experimentally, uh, especially in a static way representation. Therefore, multidisciplinary science is needed to discuss structural complexity and the dynamics of DNA molecules as a whole. So this is the physics exists in order to describe DNA dynamics when transferring genetic information through the physical modeling of DNA system. So the very first time physical model about DNA is proposed by Pierre-Bischoff model, and according to current research, there's so many development of DNA research, like genetic engineering, development of DNA model by theory and experiments, and so on. So this is the ground flow of the DNA model development. Pierre-Bischoff as the pioneer, and in this research, we investigate potential solvent in Hamiltonian DNA by Marcozzoli, but also sorry, this is should be 2011. But also we consider the DNA in a silver thermostat. So what is the physical meaning about the silver thermostat? Because in a Pierre-Bischoff model, the DNA is assumed in a vacuum condition, but in realistic, the DNA is in a cell in cytoplasma environment, so we have investigate DNA in the silver thermostat.
sugi sekarang kue mangkuk. Ginyang bana mata ci ginyang bana, panggil goyang bana mata ci goyang bana. Itu mulai kocek madakam ini sarang matang ci baju lacabi. Bakal tuntang tuntang badua tarawih, tuntang kuita tilantang, tuntang pisang di panje. Tuntang bakal tuntang tuntang badua tarawih, kuita tilantang, tuntang pisang. Si udin bingung, berhunci matanya cakong, berdua di mata maluang, urang talengnya inya manjang tuang. You Allah, you Allah, you Allah, you Allah. Pada ginyang mana mata ci ginyang mana. Sayang mulai kocek madakam ini sarang matang ci baju lacabi. Bakal tuntang tuntang badua tarawih, tuntang kuita tilantang, batang pisang di panje. Kadang makan dolar, berkadang mata banyak murah, sebuah jemaah masuk di sekadang kue mangkuk. You Allah, you Allah. Panggil ginyang bana mata ci ginyang bana, panggil goyang bana mata ci goyang bana. Itu mulai kocek madakam ini sarang matang ci baju lacabi. Bakal tuntang tuntang badua tarawih, tuntang kuita tilantang, batang pisang di panje. Tuntang bakal tuntang tuntang badua tarawih, tuntang kuita tilantang, batang pisang di panje. Sagupan sigai, tamangke makan jota pai, gulai bakuran jajo pakai ulang lagi. Aku kadang makan jelamu, barikanya batu mengantuk. Semua coba apa sugi sekarang kue mangkuk. You Allah, you Allah. Panggil ginyang bana mata ci ginyang bana, panggil goyang bana mata ci goyang bana. Itu mulai kocek madakam ini sarang matang ci baju lacabi. Bakal tuntang tuntang badua tarawih, tuntang kuita tilantang, batang pisang di panje. Tuntang bakal tuntang tuntang badua tarawih, tuntang kuita tilantang, batang pisang di panje. Kesapui si udin bingung, berhunci matanya cakong, berdua di mata maluang, urang talengnya inya manjang tuang. You Allah, you Allah, you Allah, you Allah. Pada ginyang mana mata ci ginyang mana. Sayang mulai kocek madakam ini sarang matang ci baju lacabi. Bakal tuntang tuntang badua tarawih, tuntang kuita tilantang, batang pisang di panje. You Allah, you Allah, you Allah, you Allah. Pada ginyang mana mata ci ginyang mana. Ginyang sabana ginyang, sabana ginyang, ginyang sabana ginyang, ginyang sabana ginyang. Tuntang pakai tuntang, pakai kuita tilantang, ande ibadah, ande lagi ginyang, ginyang sabana ginyang. Panjat aku panjat sigai, lama kangen makan jota pai, boleh baku kadang makan lawa, berkadang foto banyak tua, semua cuma masuk di sekadang kue mangkuk. Panggilin yang bana mata cigin yang bana, panggil goyang bana mata ci goyang bana. Itu melaku cimana kamu dia sarang melaku cibajulah cabi. Bakar kuntang kuntang badut tarawih, ketemu kita tilantang batang pisang di panje. Sugi sekadang kue mangkuk. Panggilin yang bana mata cigi